So guys, we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about histograms. Now histograms are quite important. Trust me, from this you will be able to derive even probability density function using kernel density estimation. If this terms looks very new to you, don't worry, we'll learn everything as we go ahead throughout the course. Okay, so first of all, let's take one very good example. Suppose I have a random variable like age. Okay, and then I have various values like 23, 24, 25, 30, 34, 36, 40, 50, 60, 75, 80, and these are my random variable of ages. Okay, now let's see, let's try to denote, or let's try to create a histogram of this. So how does a histogram actually look like? We are going to discuss about that. Now suppose this is my graph like ages. I'm just going to take this entire thing like an ages and just create a single dimensional points. Now here let's consider that this is 0, then I have 10, then 20, then 30, then 40, then 50, then 60, 70 and 80. Okay, so these are my points with respect to the ages, and now what I will do is that I will just try to populate the points between 10 to 20, 20 to 30, like that. I will just try to populate the points. Now what I'm going to do over here, let's see between 20 to 30 how many points are there. So 23 exists over here, so I'm just going to make a small notation over here. Then I have 24 here itself, 25 and 30. Okay, so these were my points that were actually present between 20 to 30. Okay, so here I'm just going to make a note of that. 20 to 30, how many number of points I have? 1, 2, 3, 4. Okay, 4, right? Then let's go back to 30 to 40. So here I have, just a second. So let me take another point. So here I have 30 to 40. Now in 30 to 40, let's see how many, it's greater than 30 at least. Somewhere between 30 to 40. So you have 34, 36, right? And 40 itself. So here I'm going to make another point. Here I'm going to make another point. Here I'm going to make another point, right? And similarly, I will do it for the other one. So let me just change the color. And probably if I will make it from 40 now, 41 to 50. So 41 to 50, how many number of points are there? 1 and 2. 2 points here. 30 to 40, how many points are there? 1, 2, 3, right? So let me take the blue color again, and 3 points over here, 2 points over here. Perfect. It is absolutely working fine. And now let me make the pointers over here. 40, 50 was 1 point. So 41 to 50 is only 1, right? Sorry for that. So this is only 1. So let me make it 41 to 50 is only 1 point. I'm going to note it down, that specific 1 point. Similarly, I'll make the count of everything. So I'll make the count of 50 to 60 is again 1 point. Specifically, I'll say 51 to 60. Then 61 to 70, no points, that is 0. And similarly, I'll go and I'm just making the count, the frequency, like how many number of elements are present over here. Okay. And then 71 to 80, there are 2 points, that is 75 and 80. So 75 comes over here, 80 comes over here. Okay, and probably if I go and say 61 to 70, 70 will come over here. Okay, now if I have this all points, please focus over here. How do we create a histogram? Okay, from a single dimension point, histogram is nothing but we are just counting the frequency based on bins. Okay, so over here by default, I have given the bin size as 10. So here you can see 0 to 10 is 1 bin. Okay, we basically say this as bins. Okay, so we have 1 bin over here, 10 to 20 is another bin, 20 to 30 is another bin, 30 to 40 is another bin, 40 to 50 is another bin, 50 to 60, 60 to 70. Like this, we have bins which are equidistant, like 0 to 10, 10 to 20, 20 to 30. You can also change the bin size. You can also say that how many number of bins I want. And that is also possible with the help of Python code. Okay, so here what I am actually going to do, if I really want to convert this entire thing into a histogram, all I have to do is that convert this something like this, and this axis will now become your frequency or count, and then how many number of points exist between these bins, like 20 to 30, how many number of points exist? 4, right? So we will update this count frequency like this. 1, 2, 3, and 4. Okay, and then we will start constructing buildings for this based on the count. So over here you can see that 4 is there, so I am going to make one building like this. So this basically says that from 20 to 30, how many number of variables are present in this distribution? There are around 4 values that are present, and obviously you know what are the values: 23, 24, 25, and 30. Between 30 to 50, how many numbers are there? 3 numbers are there. So I'm going to basically construct one more building over here. And remember, these values that you're seeing is continuous values. In the case of discrete values, I'll also show you one example of the discrete value just in a while. Okay, first of all, let's focus on this continuous one. With continuous, you'll get a different kind of histogram. With discrete also, you'll get a different kind of histogram. Now 40 to 50, how many values are there? Only 1 values are there. So I'm going to again construct this like this over here. And then 50 to 60, again 1. So again, I'm going to construct another building. Okay. And then 61 to 70, 0 is present. So I'm not going to construct any buildings over here like this kind of blocks. No, I'm not going to do it. 70 to 80 is basically 2. So I am going to make something like this, and this will basically get connected. Now, with respect to this particular distribution, this is what is my histograms. Now, histograms, what it is actually doing, it is just giving you the frequency of this particular distribution between bins. Okay, like this, you can change this bins also, where you just have to specify bin size, and based on the distribution, it will equally divide that entire thing. So guys, as discussed, histogram actually helps you to find out the frequency of a specific distribution, and based on that, it will try to showcase you this kind of building block structure. Now, there is one more very amazing thing that you can derive from this histogram is the probability density function. Okay, now probability density function or probability distribution function, you can see that if I try to smoothen this histogram, which looks something like this, then this will basically define your probability density function. Now the question rises is that, Krish, how do you smoothen this? Smoothen the histogram, right? How do you smoothen the histogram? So there is a concept which is called as kernel density estimator. I'm going to write it down over here. Kernel density estimator. And this we are probably just going to see after a couple of sessions in the upcoming topics. Based on this kernel density estimation, we will try to derive this kind of smoothened curve. And this smoothened curve will actually give you the probability density function based on this kind of histograms. Okay, so but I hope you have got an idea about how to construct a histogram, and with the help of code also you will be able to do it. Okay, and that example also you'll be able to see this. And one more thing that I really wanted to focus on is that understand there may be points, there may be overlap points, any number of overlap points, but when we construct a histogram, always remember one thing is that this will actually find out the frequency of the elements or the count of the elements that are ranging between the bins. This is very much important to understand. So yes, this was it in the histograms. So in the upcoming session, we'll be discussing more topics.